Let us start chapter 2, sections 5 and 6. Problem number 1. Substitute the given value into each formula and solve for the unknown variable. Problem number 1, you have D equals R times T. Substituting the 195 into D and 3 into T, we have 195 is equal to R times T, which is 3. Divide both sides by 3. 195 divided by 3 is equal to 65. The next one, V is equal to L times W times H. L is 14, W is 8, and H is 3. So V is equal to L, which is 14, times W times H. 14 times 8 times 3 is equal to 336. P is equal to A plus B plus C. P is 30, so let's substitute 30 into P is equal to A, which is 8, plus B, which is 10, plus C, which is our unknown. Combining like terms, 30 is equal to 18 plus C. Subtracting 18 from both sides, we have 30 minus 18, which is 12. And the last one of problem 1, I is 1 million, so let's substitute the 1 million into I. 1,056,000 is equal to P, which is our unknown, times R, which is our rate, 0.055, times T, which is 6. So multiplying 0.055 times 6, we have 1,056,000 is equal to P times 0.33. Solving for P, we divide both sides by 0.33. And 1,056,000 divided by 0.33 is equal to 3,200,000. Number 2. Solve for each variable. So for A is equal to pi times A times B. Solving for B, we subdivide both sides by pi A. So the pi and the A cancels and we're left with B is equal to A divided by pi A. The next problem, T is equal to M and R. Solving for N. So solving for N means we want the N alone. So we divide both sides by MR. So the M cancels, the R cancels, and we're left with the N is equal to T divided by M times R. Solving for Y. The next problem, you want Y alone, which means you're going to add X to both sides. So Y is equal to X plus 13. And the last problem from number 2, solving for H. Again, we first need to move this over to the other side. So let's subtract negative 4LW. So we have S minus 4LW is equal to 2WH. Solving for H, we divide by 2W. So that cancels, we're left with H is equal to S minus 4LW, divide that by 2W. And that is our answer for number 2. Moving on to number 3. Find each number described. What is 88% of 1,000? So let X equals our unknown number. So we have what is 88% changed into a decimal is 0.88. Of is times 1,000. So translating word for word, we have 0.88 times 1,000, which is equal to 880. Again, let me make a little side note. To divide percent divided by 100 is equal to a decimal. That's how you would change percent into a decimal, is by dividing by 100. So the second part of number 3, the number 87.2 is what percent? Again, x's are unknown, of 436. So here we're going to solve for x. So we divide both sides by 436. So x is equal to 87.2 divided by 87.2 divided by 436 is 0.20, and it asks for the percent. So changing decimal to percent, we multiply by 100. So x is equal to 20%, which is 0.20 times 100. The last problem from number 3, the number 126 is equals 35%, again dividing by 100, of what number? So solving for x, we divide both sides by 0.35, and 126 divided by 0.35 is equal to 360. Number 4, a music store is advertising 25% off sale on new releases. Find the discount and the sale price of a newly released CD that regularly sells for $12.50. So let's define our variable. Let x equals the amount of the discount. Okay, x is equal to the amount of the discount. So we have x is equal to 25%, which is 0.25 times $12.50. So 0.25 times 12.50 is equal to 3.125, which is equal to 3.13. So that is the discount. So now we have the new price is the $12.50 minus the discount of $3.13. Therefore, the new price is $9.37 is the new price. Number 5, find the original price of a popular pair of shoes if the increased price is $80 after a 25% increase. So again, let x is equal to the original price of the shoes, and let's let 0.25x is equal to the increase. So now we have the original price of the shoes, which is x, plus the increase, 0.25x is equal to $80. So combining like terms, again there's a 1, so you have 1.25x is equal to 80, divide both sides by 1.25, and 80 divided by 1.25 is equal to $64. So therefore, $64 is the original price of the shoes if the increase is $80 after the 25% increase. And the last, number 6, find last year's salary if after a 3% raise, this year's salary is $55,620. So again, let x equals to last year's salary and 0.03x is equal to the increase. So we have the last year's salary plus the increase is equal to the total amount of $55,620. Again, solving for x, you have 1.03x is equal to 55,620. Divide both sides by 1.03, so x is equal to 54,000. Therefore, last year's salary was 54,000, and this completes Chapter 2, Sections 5 and 6.